Okay, continuing from where I stopped the last time, we're discussing the um, disadvantages of the distributed operating system. So I was explaining that don't confuse the fact that this the failure of the main network will stop the entire communication. Now, first the fact that there's a network communication that communicates among these various computers. So if there's a communication of this main network, there's still a central system that controls the network. Once that goes down, then the entire system goes down. Then these types of systems are not readily available as they are very, very expensive. Um, Also, there could be security risks because most times these systems are in remote locations. So what if someone like an hacker was able to hack into this network? Then that's will probably result into security breach. So examples of distributed operating systems is locus. The next type of operating system we're going to talk about is the network operating system. Now, in the network operating system, this turns on a server and provide the capability to manage data, users, groups, security, applications, and other networking functions. This type of operating system allows shared files, printers, security, applications, and other network functions over a network. Now, advantages of network operating systems is first that it is highly stable um, because they use centralized servers. Now, because these centralized servers people have worked on them over the years. Examples of processors that are used on this server is called the Intel Xeon. You can read up on it. So they are highly stable. There's security concerns are handled through the servers. Then new technologies and hardware upgrades are easily integrated into this system. And servers access are possible remotely from different locations and types of systems. Now, the disadvantages of this type of operating system is the fact that the servers are quite costly and user has to depend on a central location for most operations. It's like your browsing. You must always communicate to the server. And maintenance and updates are required regularly. Examples of network operating systems are the Microsoft Windows Server 2019, Windows Server 2016, Microsoft Windows Server 2008, Unix, Linux itself is a network operating system. Mac operating system is also a type, Mac OS X. Then Novell, NetWare, and BSD are various types of examples. Of course, Microsoft has a lot of examples here. Windows Server 2002, 2008, and the likes. Then real-time operating system. Now, in real-time operating system, the operating system serves the as real-time systems. Now, the time interval required to process and respond to input is very, very small. This time interval is called response time. Now, they are used when there are time requirements. When time are very strict, like missile systems, air traffic control systems, and robotics. These are where application area of real-time operating systems. Now, there are two types of real-time operating systems. First are the hard real-time systems. Now, in this type of system, the operating systems are meant for applications where time constraints is very strict, and even the shortest time delay is not acceptable. For example, is in missile systems. In missile systems, 1 second is too much. 1 second is just too much. You don't have a second in missile system. You are talking missile control system. You are talking of microseconds. Then also these systems are built for saving lives, like automatic parachutes or airbags, which are required to be readily available in case of an accident. Okay, so aside the missile control system, this is another application where an automated parachute, because when you are using a parachute, there's an altitude by which you must deploy your parachute. Otherwise, the force, the weight yes, the weights are mass due to gravity. The acceleration due to gravity will increase, and that could be fatal. Also, virtual memory is almost never found in this kind of system. Virtual memory, I don't know if I've explained this in the other class, but virtual memory is the concept where you have your RAM and you have your hard drive, whereby any program that the computer is not using currently is being stored in the hard drive. And anytime the computer needs that particular program, it calls it up from the hard drive into the RAM. Now, in real-time operating systems, you don't have something like that. Everything must reside on the RAM because you need everything to function immediately in a nick of time. Then there's something called the soft sign operating system, and this time this type of operating systems, this type of operating systems, sign constraint is less strict, but that less strict still does not mean you are talking of minutes. You are still talking in seconds, but just that in the first part, which is the hard read time, you are talking of 10 microseconds, between 3 and 10 microseconds. That's a very fast time. 3 to 10 microseconds is very, very, very fast. While in software, maybe anything more than 10 microseconds. In both cases, it is still not, you are not even still talking of seconds, you're talking of microseconds. Now, what are the advantages of real-time operating system? First is the fact that maximum utilization of devices and systems, thus providing more output from all the resources because you are utilizing your resources maximally. Then time assigned for shifting tasks in this system are very low. Focus on running applications and less importance on queues. There's nothing like queues. Nothing, they are dedicated. And since size of programs are small, real-time operating systems can also be used in embedded systems like in transport and others. These types of systems these types of systems have less errors. Let me add that. Okay, so it's been added. Then again, memory allocation is best managed in this type of system. Like I said, we are not talking about virtual memory here. Then disadvantages is the fact that first, very few tasks run at the same time, and their concentration is on few applications to avoid errors. Very few tasks run at the same time. If you are controlling the direction of a missile, you are not at the same time. You don't want to start continuing that missile to blow at that time. Then requires sophisticated system resources, and they are expensive as well. Algorithms are very complex and difficult. It needs specific device drivers and interrupt signals to respond to. Excuse me. Yeah. So it needs specific device drivers and interrupt signals to respond earliest to interrupts. It is not good to set try priority as these systems are less prone to switching tasks. Okay, moving on to kernel. Now, what is a kernel in operating system? Now, a kernel is a program at the core of the computer's operating system with complete control over everything in the system. The kernel is a part of the operating system that interacts directly with the hardware of the computer. It is an integral part of any operating system. It is the portion of the operating system code that is always resident in the memory of the system. It facilitates interaction between hardware and software components. On most systems, it is one of the first programs loaded on startup after the bootloader. Of course, the bootloader is what loads the operating system. But immediately after the bootloader the next thing that loads is the system kernel, which is the operating system kernel. It handles the rest of the startup, as well as input and output requests from software, translating them into data processing instructions for the central processing unit. It handles memory and peripherals like keyboards, monitors, printers, and speakers. Now, there are two types of operating system kernels. First is the microkernel, but the second is the monolithic kernel. I'll stop this video now. Then I'll continue in the next video.